Go over finding points on a line, and they've given us this equation of a line. Okay, now just kind of a recap: an equation of a line. The y stands for all of the y points on a graph, and then usually they have mx plus b. Is this familiar to you?
A little bit.
A little bit. The m stands for the slope. Okay.
Okay.
And the b stands for the y-intercept. So in this case, the y-intercept is 3, and the slope happens to be 3 also. Okay, but more importantly, those aren't too important. Just to recap, we want to test to see if these points fall on this specific line. Okay, so we're going to test point A. Now, when we have a coordinate, one of the numbers stands for an x value, and one of them stands for a y. Do you know which is which?
The right is for the x and the y. This the left is for the left is for the x and right is for y.
That's right. Yeah. So the first one, when we're reading it, would be the x, and the second one would be the y value. Okay. So a way we can test this is, because this is an equation, an equal sign. Think of it like something that's saying that this is balanced. What they're saying is the value of y is balanced or equal with 3 times the value of x plus 3. Okay. So let's test this. One way we can test this is by plugging the 2 value in for our x and the 7 in for the y. Okay, so what we're going to do here is we're going to replace the x value with 2, and we're going to replace the y value with 7. Okay, so let's start this out and see if this works. So we'll do this one in red because we're testing a, which happened to be red. So again, we'll write it out. Y equals 3x plus 3. So we're going to replace x, and we're going to replace y. Well, we said we're going to replace y with 7. So 7 is equal to 3. And we're going to replace x with 2 times 2. So I put brackets around what we just replaced, okay? Plus 3. So what we've just done is we replaced the x value with the number 2 and the y value with the number 7. And that's what this coordinate was, 2 and 7. And we're going to check to see if the left side is equal to the right side. Okay. So on the left side, there's nothing really there. It's just one number. So we're just going to leave it as 7. On the right side, I have kind of two operations. This says 3 times 2 plus 3. So what do we do first?
The 3 times 2.
That's right. Do you know what 3 times 2 is off the top of your head?
6.
Yeah. So we have 6 and then plus 3. What would that be?
9.
Yeah. So does 7 equal 9? No, so this is unequal, okay? That's what that sign's for. It doesn't equal. So in other words, A, no, it doesn't fall on this line, okay? So that's what we found. Because the left side didn't equal the right, so that means point A didn't fall. Okay, well, let's test point B. Again, like you said, this is the x value, this is the y value. So we use the exact same equation. Again, so we have y equals 3x plus 3. And we said we're going to replace, and I'll change the color so it's a little nicer here, easier to see. We'll replace the x with -2, and do purple for the y. And the y with -3. And we're going to test the exact same thing again. Okay, so this one's going to read -3, replace the y with that, is equal to 3 multiplied by, and we replace the x with our -2, plus 3. Does this make sense what I've done so far? So same idea as before. We replaced our x value in the equation with -2. And we replaced the y value in the equation with -3. Okay, so we're balancing our equation to see if these are equal. So again, the left side is just -3. There's nothing to simplify. So -3 is equal to, now here we go, we have 3 times -2. Do you know what that will be?
-6.
That's right, that'll be -6. And we'll have -6 plus 3. This can be confusing. Do you know how to do integer addition and subtraction?
A negative times a positive is a positive.
Yeah, but this one's adding.
Oh, okay.
Yeah.
So then it's a negative.
Yeah. So this one says -6 plus 3. And if you want to grab that calculator, I'm going to tell you what it is. It just so happens that it's going to be -3. Okay, so is this one equal in the end?
Yeah.
Yeah. So because we have -3 is equal to -3, that means yes, point B is on the line. So point A didn't fall on our line, but point B did. I'm just going to check something real quick. You're doing good. We're going to verify. Have you done graphing linear equations yet? Have you graphed something like this before?
Yeah.
So I'm going to quickly graph it and then plot these points to double check that we're right. Now we don't have to. We've proven that it's right, but it's good practice to do something like that. Be like, okay, I just want to double check something here. So I'm going to bring up a graph. So this is easy for me because I have pre-made graphs already. Okay. So this is where the y-intercept and the slope come in handy. Scroll on up. Remember we said our y-intercept was 3 and the slope was 3. So a y-intercept is where we cross the y-axis. So I cross the y-axis at the value of 3. Okay, remember our equation was y equals 3x plus 3.
Okay.
So that was that. And our slope, they usually write as a fraction. And I can make any whole number a fraction by just putting it over 1. So the rise is 3. So it says I can go up 3 because it's positive 1, 2, 3. And I can go run 1, so positive direction 1. So here's our slope. So we go up 3 over 1. We go up 1, 2, 3 over 1. Or we could do the reverse, down 1, 2, 3, and the other way 1. And here we're going to have our linear equation. Okay, so it's kind of going down like that. So there's our line. One of the coordinates was 2 and 7. Well, at 2 and 7, that was our A point. A was at 2 and 7. Did that fall on our line?
No.
No. So there you go. That made sense. And the other one we had was -2 and -3. That was our B point. Did that fall on the line? Was that on where our line is?
Oh, yeah.
Yeah, it was. So that was our check. So we were right. That point fell on the line where the 2 and 7, our A point, didn't fall on the line. Okay? So that's how we check for this process.